Hey everybody, this is Larry. This is day whew, day 13. Oh, Friday the 13th. Wow. Hope everyone's having a good Friday the 13th. Ah, actually I like this wallpaper background. It makes me looks like I intentionally care for setting this up or something, you know? It looks also like very Instagrammable. I don't know. Let me know if it matches my skin tone or whatever. I don't know what even know what that means, but it looks very like I don't know. Now I feel like uh no, I'm doing this professionally or something. Oh, snap, maybe. Yeah, sorry, I was just looking at my camera. I didn't even look at the farm yet. As I don't know if I mentioned it yesterday. I think I did at the end, but you might not have, caught it just because I was just so out of it. But I'm in Taipei right now. It is 8-ish a.m. I need to do some errands. But follow me on Instagram if you're kind of curious what I'm up to. I promise I will post way too much, and you'll almost feel like you're there with me. Huh, if you want to be anyway. I don't know. I mean, I do pretty boring things. I'm saying you can do boring things with me. Anyway, all right. Today's a easy problem, so hopefully, you enjoyed that or the amusement for now. But today's problem is 746, min cost climbing stairs. Okay, so you're given an array, cost and cost of I, where the cost of I step on a staircase. Once you pay the cost, you can climb one or two steps. So, okay, like Fibonacci, but with a cost and minimize it, I suppose. Right? Yeah, minimize it. So, okay. I mean, there are a couple of ways you can do it. Really bottoms up, tops down, space optimization. All the usual thing. Is this the start of dynamic programming week? I guess we will find out. But for now, I mean, I think yeah, I mean, I think this is one of those things that hopefully you're not struggling with, and if you're struggling with, there's no shame because if you're struggling with, it just means that you haven't learned this yet. Because this is probably one of the most basic things. Definitely read about Fibonacci and all those things, but yeah, I mean, otherwise, you can do this a number of ways, and yeah, the idea and. I'm gonna see if I could do this off. I probably already have like 3 or 4 videos on this already. Maybe at least two, maybe. So I'm gonna try to not kind of do the same thing because I probably just did the tops down with the memorization thing, right? No, I did not. So okay, I lied. So okay, so the last video, I was gonna just write it this way. The last video. And then this is the way that I did it the first time. I guess I did it both ways, but this is pretty basic. So I don't know. Man, I was gonna do the space optimization this time and be like, look. But okay, fine. But yeah, I mean, to be frank, there's really not much complicated about it. The idea is that like you have some f of x that's equal to some function of, some function of f of x minus 1, f of x minus 2, right? And that's really all that is, right? That's the recurrence, and the g function is actually the min function. So, yeah. And technically this is, plus some constant, right? But that's basically the idea. That's kind of what the function is. So, yeah. And yeah, and once you have a recurrence, the way I do it is just kind of do it recursively, right? By writing it out directly, right? So now we have some x, and in this case, let's just say it's index, just so it's slightly easier to read. And we can go from, this is also one of those problems that I actually mention a lot, right? Well, I try to, I don't know if I do anymore, but definitely in the past, where this is symmetric, right? Meaning you can go from the beginning to the end or the end to the beginning and it has the same thing because addition is commutative, right? Yeah. So, so what I want to emphasize that is that it's easy to get it right, but or it's easy to get the right answer, but you may not be consistent in the direction, which does not penalize in this one because it's symmetric, but it may impede you on future problems. Definitely be aware of it. And in this particular problem, it doesn't matter, so it's fine. I'm going to just go left to right or from bottom to top. So technically this form is wrong, but yeah, let's do it this way, right? If index is 0, 0, then we return cost of 0, and that's it, right? And we have to go there anyway. That's the base case. Otherwise, we return min of f of index minus 1, f f of index minus 2 plus cost of index, right? And that's really pretty much it. Return f of n minus 1, where n is equal to length of cost. That's pretty much it. I know we have to do memorization, but oh yeah, okay, fine. I guess I'm a little bit sloppy on this one. I guess the cleaner way to do it is that this is case, return 0. Fine. Alright, so apparently it's very easy to get wrong. Oh, because you cannot jump over. Okay, fine. Definitely rushed this a little bit and a little bit sloppy. But yeah, 15. Did I misunderstand this? Oh, I actually, I mean, I didn't misunderstand. I just literally missed this case. All right, well, so that means, you know, that's pretty much it. Right? But but that also means that we don't have to. I think I messed this up. So even despite me saying how easy it is, I kind of misunderstood misunderstand some base case. So the base case is going to be, you know, you can go afterwards. So yeah, okay, fine. There probably you can do something better about this, but fine. Yeah, okay, right. Yeah, and of course, next step is memorization. This branches out has a branch factor of 2, which means that this is, you know, exponential. And of course, if you know your Fibonacci series, this is actually x to the like 1.6 or whatever it is, right? 1.616. You know, Fibonacci stuff. I'm not gonna get into it that quick. Soon. And also maybe I'm wrong. It's been a while. So, and if I am wrong, then but it's still, it is exponential, and that means that for n is, well, 1,000, it doesn't really need the exponent to be big to make a huge impact. So you want to memorize this, and there are a couple of ways you can do it. I know people always tell me to just use cash. If you don't know what that means, then don't worry about it, but I like to write it out. It's a little bit easier to understand, maybe not, I don't know. But it is easier to analyze the space and time, because now the index can only go from 0 to n, and we do 2 operations per input. Not 2 operations per se, obviously there's more, but just like 2 lookup operations. So yeah, so this is going to be O of n once we cache it. So let's do it. But yeah, kind of, I would also point out that the symmetry stuff, you know, it probably is easier to write it the other way, but you have to be really careful about how you do the dynamic program, because you can see that the base case is that, you know, this is, I have to change this and I have to add this to kind of accommodate it for it. I mean, the structure is still mostly the same, but you just have to be careful. It is very easy to get wrong, right? And that's pretty much the idea. So yeah, let's go submit. Hopefully I didn't really mess up after saying how easy, talking about how easy it is. I messed up a couple times, and then it's gonna be even more messed up. That'll be a little bit silly. But yeah, that's all I have for this one. That's all I have for today. Let me know what you think. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.